Hello viewers, you are watching my channel Mechanical Zone. In this video, we will discuss numericals on center of buoyancy and Archimedes principle. So let us directly solve the numericals. First question is, find the volume of water displaced and the position of center of buoyancy for a wooden block of width 2.5 meter and depth 1.5 meter when it's float horizontally in water. The density of the wooden block is 650 kg per meter cube and its length is 6 meter. So what are the data that are given? The data are the width of the block is 2.5 meter. The depth of the block is 1.5 meter. It is floating horizontally in the water. The density of the wooden block is 650 kg per meter cube. Its length is 6 meter. Much data is given. Another point is given, which is that the wooden block, it is floating horizontally in the water. So let us draw a figure with reference to the question. So this is the wooden block. As it is floating, that means some part is outside the water and some part is inside the water. So this is the free surface of the water. That means this part is the water and the wooden block is floating like this. And this is the width of the wooden block, which is 2.5 meter. And this is the depth of the wooden block, which is 1.5 meter. And h is the depth which is inside the water. So this is the, consider this point is as the centroid of the wooden block and this point as the center of buoyancy. So what next step we will do? We will calculate the weight of the wooden block. Suppose let the weight of the wooden block as W. In order to calculate, we need to put the formula rho g v. What is rho? Rho is the density of the wooden block, g is the acceleration due to gravity, and v is the volume. How we will get the volume? We will multiply these three values: length, width, and depth of the wooden block, and we will get the value of the volume. I can write the formula like this also: W T L. So let us put the values. Density is 650 kg per meter cube. G is 9.81 meter per second square. W is 2.5. V is 1.5. L is 6. From here, you will get the value of weight in terms of Newton. So, with this, we have calculated the weight of the wooden block. As the body or the block is floating in the water, that means the weight of the water displaced will be the weight of the wooden block. So I can say the weight of the water displaced will be similar to this formula, which is the density of water into G into volume of water displaced, and weight of the wooden block, you have this. Let us suppose this is the value x. The weight of the wooden block is x. As we have calculated the value, we put the value over here and do the calculation part. The density of water is 10 to the power 3 or 1000 kg per meter cube. G is 9.81 kg per meter per second square. VW is X. From here, VW will be X divided by 10 to the power 3 into point. You will get the value of volume of water displaced in terms of meter cube. This is the first part of the answer. This is the first answer which is given. Then, what is the position of center of buoyancy? So, in order to calculate the position of center of buoyancy, you need to calculate the value of H. We got the value of volume of water that is displaced. So, your volume of water displaced will be equals to the volume of wooden block which is inside the water. So, you can write it like this: the volume of water displaced, this is volume of water displaced, is equals to volume of wooden block inside water. So, if you will see the figure, you will easily know that the volume of wooden block which is inside the water is width into this depth, that is h, and the length which is 6 meter. So, I can say that the volume which you have already calculated, let say the value is y. So, y will be equals to volume of the wooden block which have the formula width of the wooden block into depth, that is the amount of wooden block, that is the depth of wooden block inside the water, into length. So, you have the value of W and L. You can easily calculate the value of H. So, which will be equals to y by W is your 2.5 meter, L is 6 meter. You can easily calculate the value of H in terms of meter. So, you have got the value of H. That means the height or the depth the wooden block inside the water. So, in order to calculate the center of buoyancy, you need to calculate the centroid of the part of the wooden block inside the water. In order to calculate the centroid of the part of the wooden block inside the water, you need to divide h by 2, which will be this value. By doing h by 2, you will get the center of buoyancy. So, that means the position of center of buoyancy, from the free surface of the liquid or from the base, whatever you can consider, from the free surface of the liquid or from the base, which will be equal to h by 2, you will get in terms of meter. So, with this, like this, you can solve or you can calculate the value of center of buoyancy and volume of water displaced, volume of wooden block inside the water, weight of the wooden block inside the weight of the wooden block. Like this, whatever unknown is given, you can calculate. The steps to be followed, this will be like this. And I have not done the calculation, you do the part of calculation. So, after that, we will solve another problem, another numerical, which is on the principle of Archimedes, or we can say that it is on Archimedes principle. Let us read the question. A stone weighs 392.4 Newton in air and 196.2 Newton in water. compute the volume of the stone and its specific gravity. You need to calculate the volume of the stone and specific gravity. What is the data are given? The data are, let us solve it. The data are weight of the stone in air. I'm writing WA, weight of the stone in air is 392.4 Newton, and weight of the stone in water is equals to 196.2 Newton. So you know that by Archimedes principle, if a body is completely if a body is completely inside the water, that means the weight of stone in air minus weight of stone in water is equals to weight of the water displaced. Weight of the water displaced. This is for the case where it is completely inside the water, or you can say this is the Archimedes principle. So WA minus WW will be equals to the weight of the water displaced, which will be rho W, that means density of the water, G, acceleration due to gravity, and volume of the water displaced into volume of the water displaced. So you can easily sense that the rho GV formula is quite common. So we have the value of WA 392.4, WW 196.2, which will be equals to density of water is 10 to the power 3 kg per meter cube, G is 9.81 meter per second square, and let us consider the volume of water displaced as VW. So you will get the volume of water displaced like this. If you do the subtraction, that will be again 392 minus 196.2 will be 196.2 divided by 10 to the power 3 into 9.81. We will get the value or volume in terms of meter cube. Okay. What else we will do right now? We have got the volume of stone or volume of water displaced, which will be equals to the volume of the stone. Volume of the stone. It's quite simple. After that, what we will do? We have calculated the value of a stone or volume of the stone, which is the first part of the answer. Then let us go to the second part of the answer. We need to calculate the specific gravity of the stone, and in order to calculate the specific gravity of the stone, as we are comparing this with the liquid, we will consider the liquid as water and we will do the calculation. So we need to calculate the mass of the stone. So mass, how we will calculate? Weight in air. Don't take the weight in water, take the weight in air divided by G, as mass is equals to mg. Weight is equals to mg, so mass will be weight divided by G, and that formula is applicable for the case of water, for the case of air. From here, weight in air is 392.4, G is 9.81. You will get the value of mass in kg. We got the value of mass. After that, what we will do? This is as m. This is m. This is not clear, but this is m. Then density. We will calculate the density when denoting by rho density of the stone. That is mass in air divided by volume of the stone, which we have calculated. The mass in air, suppose the volume is x and x meter cube. We have calculated the value as x meter cube. So as I have written the formulas, written the values, you do the calculation part, you write the value of x over here, because you do the calculation part. The mass of the stone is y, as we have done the calculation. If we'll do the calculation, we'll get the value of y. So the density will be mass is y divided by x, volume is x. We will get the density in terms of kg per meter cube, because your y is in kg, x is in meter cube, but you will have the actual value because you have calculated the value of y and x. Then the specific gravity of the stone. Why I never do the calculation part in my discussion, because if I'll do the calculation part, what will happen? The things will be easier. It will be like copying the thing and writing the thing over your note, and this will completely remove the interest of solving a numerical. So that is why I'm not doing the calculation part. I'm putting that part on you, so you do that task. I am telling you the way, I am showing you the way how you can do the calculation or how you can solve a numerical. So last part, how you can calculate the specific gravity of the stone. So in order to calculate the specific gravity of the stone, we have the formula, density of the stone, and we are calculating the specific gravity with respect to water, the density of water. You have already calculated the value of density of the stone, that is rho s here, by density of the water is 10 to the power 3 kg per meter cube. By this, you will easily get the value of specific gravity of the stone. This is the answer of the second part. So like this, we have implemented Archimedes principle in order to solve a numerical, or like this you can solve numericals on Archimedes principle. Hope you must have enjoyed the session and you must have learned something. So last but not the least, don't forget to like and share my videos, and don't forget to subscribe my channel. Thank you everyone. Hope we'll meet soon.